KEET TV presents Homework Hotline, the after-school show that fuses learning with fun. Watch local teachers bring the classroom on air and online. This is Homework Hotline.
Welcome to Homework Hotline. I'm Ken Pinkerton. I'm a retired science teacher from Zane Middle School.
And I'm Jody Himango. I am the current science teacher of 7th grade at McKinleyville Middle School.
Woohoo. And we're here to share some cool stuff in math and science. And Jody's brought some wonderful stuff, some leaves. So tell me what you're going to do today.
Okay, so today we are going to use floating leaf discs to show photosynthesis.
Cool.
Which is pretty hard to show in the classroom. It's hard to observe directly. So we're going to do an indirect observation of photosynthesis.
With some pretty cool science involved in density and...
Yeah, actually much more science than you can squeeze in 30 minutes.
Yes.
Or even one class period. This is one that I actually do with my 7th grade students. So once we're studying cells and chloroplasts, this is one that we do to model photosynthesis.
Very cool.
So we also wanted to talk about the math.
Yeah, the Humboldt Math Festival is coming up. We're resurging from the COVID shutdown for the last couple of years. So it's a free event at the Adorney Center. It's all kinds of great free activities in math, science, engineering, and art. It's free and it's put on by local teachers and students. So come on down. If you want to check it out, it's humboldtmathfestival.weebly.com. And you'll find more, or if you're on Facebook, you can check it out. There's a Facebook group.
Excellent.
So it's fun with math, and as it should be.
Just what every student wants to do on Saturday afternoon.
Yeah, that's right. Well, what's great is sometimes kids are dragged in there by their parents, and then they don't want to leave. So that it's a really cool event.
More fun than you might expect.
Yes, because it's.
All right, so let's get started here. And here's a little bit of background information on what we're going to do. So what we're going to do is we're going to punch leaf discs using a hole punch. We're going to flood those leaf discs with a baking soda water soap solution. The baking soda is going to provide a source of carbon for the photosynthesis. The water is going to weight down and fill and increase the density of the leaf discs, so they sink to the bottom. Normally they would float because they have air spaces in there. And then what we're going to watch for, we're going to put them under a light bank, and what we're going to watch for is the discs to begin floating. So as the chloroplasts do photosynthesis under the light bank, oxygen is going to be produced and fill the leaf spaces back up with gas, and they're going to become less dense, and we'll start to see them float.
Very cool.
It's not instantaneous. It takes a couple minutes.
Right.
And if we had time, which I don't know if we will, but we could also watch them sink back down because the oxygen would get used up by cellular respiration.
Oh, very cool.
So you could, it's an indirect measurement of both if you're willing to wait that amount of time. So then we'll take a look at our materials list. It's pretty basic. This is even something you could probably do at home. We're going to make a 2/10 solution with baking soda and water. We need a stir stick. We're going to use liquid soap, about 1 milliliter, so I brought an eyedropper for that. We're going to use a plastic syringe with the needle removed to make a vacuum to force the liquid into the leaf spaces. We need a beaker, and here's the syringe. We need a beaker, and then we're going to need some water, a light source, a hole punch, timer, and then leaves. In my 7th grade classroom when I do this, I like to use spinach. It's not in any way dangerous. They always eat stuff. I don't know why. And it's not going to cause any kind of irritation to the skin or anything.
Not one you do with poison oak then. So that's
yeah, not one that you do with poison oak. That would be a very bad idea.
Yeah.
So all of these things would be readily available. This might be the hardest thing to get. And these are all from the vet.
Right, and you can get them from the pharmacy. I'll just go to a drugstore and ask for the pharmacy, and they have lots of syringe bodies often behind the thing, or they can give them to you now.
So this is easy to get to. So if you wanted to do this for a science fair project, or you just wanted to try it at home because it's pretty cool, you totally can. Okay, so let's get started on setting this up. So we're going to use the hole punch to make 10 leaf discs. And the leaves that we have, so I mentioned spinach and English ivy, but any leaf, here's the ivy. So it's a tough leaf. It's got a waxy coating. These work really well. You want to avoid leaves that are fuzzy, if you can. Spinach is great. And also the fresher the better, in my opinion. If it starts to get wilty, it's harder to hole punch them. And I also brought some passion flower, which is common around here, which I think would work well, but I've never personally tried it.
Cool. And
So
it's got that nice thick. Okay, cool.
yeah, it's nice, thick, cuticle, kind of a heavily structured leaf, so that's kind of nice. So if you want, I can hole punch, and then do you want to do a mix of leaves? They might be hard to identify, but we have more than one beaker that we could put them in. Or do you want to do
let's
all
do a
one
mix.
time?
That would be fun to just.
Okay.
You said you never tried passion fruit, or passion flower.
Yeah.
Maybe we can compare it. It might be your new
All right.
gold standard.
It might be. And it grows right on campus, so that's easy.
Nice.
Do you want to make this a baking soda solution? So here's the baking soda. Here's the 1/8 teaspoon.
Okay, and then water.
And actually, the measurements, what I find is if I don't always measure that carefully. And then 300 milliliters of water.
Okay.
Because sometimes I want actually a little more baking soda in there to make sure that the reaction is happening as quickly as possible.
So, and again, you said it supplies a whole bunch of carbon dioxide, or?
Yes,
Okay.
for the photosynthesis.
And then one.
And then 1 scoop, and then here's the stir stick,
Okay.
and we're going to add 1 milliliter of the soap,
Okay, great.
the dish soap.
So just a level one of these.
And when we do this in my classroom, some of my classroom plants also have holes punched in them. Even though there was an instruction, don't punch the living plants. So I have an orchid with holes down the leaf. It looks kind of cool.
Do you want me to make two batches of this in the beakers?
Sure, yeah.
And then just a squirt of this, you say? Or
1 milliliter. So if you
Okay.
wanted to measure, you could, but a squirt, we don't want to make it foamy.
Okay, so just a very small amount.
Yeah, and not too much agitation.
Okay.
So here's our passion flower.
Okay.
And then I'm going to punch the ivy over here.
So at first we're going to make the leaves less dense by pulling all the air out of them so they'll sink. And then the photosynthesis will produce oxygen.
To make them more buoyant.
More buoyant, so less dense, less dense, so they'll
Yeah.
float. So I just put a little bit in. I didn't have you check me, but.
Okay, I trust you.
Okay, and then.
So we're going to need to put some of them. So we're going to use the syringe. You have to take it apart, pull this off. We need to put the leaf discs in here, and then we'll need some of the solution in here as well. So do you want to start with the passion flower vine?
Yes.
Okay. So one thing that I noticed, so you want to avoid the leaf veins, and then sometimes it's easy to just kind of push them. It's kind of hard to pick them up.
Mm-hmm.
So what I try to do is just slide them in from the edge of the table.
Good. Practical tips.
Yes, practical tips if you're trying to do this at home. And if you're doing it with like 112-year-olds, you have to be ready with the practical tips.
That's right. Try this.
Otherwise, you watch a lot of struggling for the day.
Right.
All right.
Especially people who bite their fingernails.
Yeah, right. So we're going to put this in. We don't want to crunch or
So you do it
squish
gently.
yep.
Okay.
And then, and one of my leaf discs got shoved into there. So you want to pull up some of the solution into that.
How much? Just doesn't matter.
Yeah, it's not too important.
Okay.
And then what you want to do is hold it
Plug
up,
it.
and you want to actually get rid of all the
With
air
the oxygen,
first.
Okay.
Yeah, so we want to get rid of the air. And note if you can see,
Okay.
there you go, perfect.
And then pull it back?
And then you're going to pull it back, which is actually, as you can probably guess, kind of difficult.
Yeah.
And you want to do that 3 to 4 times. So you want to wait until your leaf discs
I'll hold
sink.
it still. So, okay, yeah, because you can actually see the,
But if you release, they'll float again if they're not.
right, if they're not
Yep,
ready. So
there you go. So see how they're starting to sink already?
nice.
But I would do it 3 to 4 times because you really want to flood those leaf spaces,
Okay.
the air spaces.
So I don't know if they can see, but what's kind of cool is that you're. So the sink, I think they are all sinking now, but I'll do
Okay.
one more time
Yeah,
for good
because
luck.
that one's kind of sort of wanting to float.
Okay. Okay. I'll put the oxygen, yeah, so they all sank pretty good. And
Excellent. So now we're going to put them into our glass beaker, which is kind of, so you kind of have to just it might be
gently.
a little bit messy, but it's just baking soda and soap and water, so.
Okay. Okay, and then I'll pour the rest of this in.
Well, we can do some for the ivy too.
Okay.
And then what I would double check is to make sure they all sunk. So
So I'll put them on the, here. I think.
yep. And then we can switch on the light source. And I'm going to turn on the timer. So we're trying to measure the rate of photosynthesis. And I put him under the light bank. We can set up our other.
Okay, yeah, and I'll do another batch.
Yep, we can do another batch. So I'm going to hit start on this. And we kind of have to keep an eye on it.
So we want to time when we first see one rise.
Right, we're going to go ahead and count all the way through.
I'm going to grab a paper towel and see if I can wipe off some of those bubbles on the top.
Yeah. So the bubbles on the top, they don't really mess up your project, but they do kind of obscure the viewing. So
Hard to see.
we'll just scoop them off.
How's that?
That's good.
Okay.
I guess I could be making the baking soda solution here while you do that. And I'm going to be kind of liberal with this since we're on limited time. Just put that much.
So
And
we're
then
double dosing then.
We're going to double dose the ivy.
And that's an important part of chemical reactions is concentration, right?
Right.
So if you increase the concentration,
Oops.
just like adding sugar to your tea, you're increasing the concentration, and so you get a faster reaction on your tongue or
Okay, and we want, if you wanted to measure, about 1 drop is about a milliliter. So if
Okay.
you wanted to measure the soap, you could use something like an eyedropper to do that, but I'll also just put a little bit in.
ooh, I think I'm seeing
And you can actually,
some movement.
yeah, you
not
will be able
floating
to see them kind of start popping up maybe a little bit to the, even just kind of standing up on edge.
Something, right? I'm seeing some color changes, I think, too.
And if you wanted to do this either in your classroom or you wanted to do this at home, you could come up with different questions that you wanted to try to investigate. So you could try different leaves. You could even try different concentrations of baking soda.
And then temperature?
Temperature would be great.
Different
yeah.
kinds of light. You could try like a full spectrum lights to see if they really help with photosynthesis or not. Or
Yeah, any of those would be great suggestions. Different types of plants, if I didn't already say that.
if I lower it, will I get more intensity, do you think, or does it make any difference?
They might, just because of the hood, might be a little more reflective.
Okay, I'll lower it just to.
And there's a couple ways to fill this. So if you wanted to fill it, once they're wet, the leaf discs kind of stick to the side. So if in a classroom, if you were doing it
okay.
over and over again, so if teachers are watching and they want to do this, once it's
syringes.
wet, they kind of stick. So you can just plug this and fill it from the top.
Okay.
So that, because again, you don't want to crush your discs. Never want to crush the discs,
Nice.
no matter what kind of discs you're talking about. And then I'm going to just put this upside down. I want to squeeze out all that air. Woo!
It's so good to see somebody else make a mess.
Science is messy, for sure. I know, and that's fun. So I'm going to push out some of the foam just to try to get rid of it. And then once again, what I'm going to do is cap it with my finger. And then I'm going to pull back on the syringe, and then I'm making a little vacuum in there. And what's going to happen is I'm forcing the liquid into the air spaces in the leaf, just to review. And I want all my discs to be sitting at the bottom, which they now are.
That's great. That was fast.
Yeah. So
see if I can get the solution.
When we'll put these in a different beaker, so that, just so we know. The English ivy is going to go in the plastic beaker.
Okay.
Maybe I'll do it once more, just to make sure. Can't hurt.
Yep.
Once it's saturated, no more will go in there, so there's nothing.
And sometimes they do this in cooking too, where you put something underneath a vacuum to what's it called, marinate it. They'll do it. So
I didn't know
it
that.
just speeds it up. So
Do you have the book, like the chemistry of cooking, or have you ever read that?
I've seen that. Yeah,
Yeah.
that's a good one. So. And
haven't
then I know
used it.
when we did tissues for making slides, we'd put things underneath vacuum, so it would increase the rate at which the preservatives would go into tissue cells. And
Very cool.
So,
Very cool.
So it's pretty neat.
Learn something new every day. So then this is another kind of critical piece. I'm gonna pull the back of the syringe out, the plunger, right over the beaker, so they just drop down in there. I'm going to double check and make sure that they're sinking, and they are.
So we put this more in the
So
center.
they look pretty cool. And then we'll squeeze this under here. Just get it as close as we can.
Should we turn it sideways so we can see both of them? Or
Sure. That would be amazing.
I'll try to try not to drop it into the water. There we go. Very cool. So I see. I don't know if it's just on this one I see kind of light spots, so I don't know if that's because of the way it naturally was before, or if that's evidence of the tissue.
Oh, right.
Yeah. So.
Well, and I wonder if this leaf doesn't have as thick of a cuticle as the ivy, and I wonder if there was like tissue damage when we were doing the
that
vacuum.
kind of stuff. So what's going on inside the leaves then? Then the photosynthesis is happening, right?
So we hope photosynthesis is happening. And you know what? Looking at our timer, it's been 6 minutes. And so it kind of takes some time. So again, in the leaf spaces, we're waiting for oxygen to build up.
Right.
And that will make them more buoyant. So they'll start to float to the surface.
So you're actually timing the respiration, how quickly the photosynthesis is happening.
Right.
Then, so
In this case.
In this case, too.
And you could run different experiments and test different things if you wanted.
Very cool.
So we're just going to, and then when you're done, you can graph your results. You could do a line graph to show kind of what you observed.
Right.
Which would be fun.
Yeah, nice to just see which, and it would be yeah, I think for science work, probably, like you said, you could try different lights and you could try different concentrations and different leaves, and so there's a whole lot of science you could do in this too. And then a really simple experiment we used to do is if you put lettuce inside of like a glass jar or a baggie and fill it with water, you'll see, and put it in light, you'll see bubbles appearing.
Yeah, we could do that. We have all the materials actually, if you wanted.
I don't know if it'll do it that quickly, but it's a neat way. I haven't done it in a long time to see how fast it'll do it, but it's a neat way to also see the photosynthesis and oxygen being produced by plants.
Right.
So.
And some of those experiments, they're kind of subject to student error. So this is kind of a good one where you can get pretty reliable results.
A lot more controlled.
Right.
Very cool.
Pretty reliable results even with kids doing it.
Yeah. And so you say spinach you like because it's edible, but it also works really well as a plant.
And we oftentimes have it in our cafeteria. But I have definitely used ivy because ivy locally is invasive. So might as well cut it down.
Get something good out of it.
Yeah, totally. It's good for experiments.
Right.
And so what I have my students do is kind of monitor as we go. We don't have much happening yet, but that's okay.
It's okay. Sometimes science is slow.
Sometimes it is slow.
Often it is. So,
Oftentimes it's very slow.
yeah.
So I did bring, while we're, and you should check every minute. So if you were doing this, I would want students to record every minute,
Right.
even if what they observed was 0 floating.
Right, because that's an observation. Right?
Yeah.
Nothing happening or nothing appearing to happening is something happening, right?
Right.
So very cool.
So we have a data table for them to record, and we record at each minute interval. So if we were doing this and writing down our results, we would have recorded 8 minutes.
Right, and you can record the number that are happening too, so that gives you even more. You're not just watching one disc; you're watching a variety of discs. So that's neat.
And for some reason, some go really fast and some go really slow. And so you could even run experiments about where's the position of the leaf, or what time did you pick the leaf? Did you pick it in the morning when the sun was high? Did you get it from the shade?
Yeah.
Did you get it? So I think there's a lot of factors that we haven't really considered when we're doing this experiment that you could consider more carefully if you wanted to do this. And you could definitely do larger numbers of discs.
Yeah.
So we only did 5 of each, but you could certainly do 10 of each.
And in the time that you've done this, what's probably the fastest you've ever seen a result?
That's a good question, and I was thinking about that when I've seen it in the classroom. And honestly, I think about 4 minutes in.
Okay, cool.
And then, everybody oohs and ahs at that one, and the rest of us are just slow waiting around.
That's the champion one. Oh, I think we have one on the side.
Oh yeah, and it looks like I can
rising.
literally see it moving.
I'm going to try and turn it really slowly. And
it's just turning.
We have 2 of them.
Yeah, so that was at 10 minutes in.
Yeah. So we have 1 at the surface, and 2 of them are rising.
So definitely once it starts to happen, it seems like they all kind of, there's definitely a predictable pattern that happens once a couple start to rise, they all kind of follow suit.
And then when they get to the top, some of the cellular respiration or the oxygen comes off the outside and they become more dense and sink, right?
Well, right, and as
sort of lava lamps and leaves.
Yeah, as the mitochondria use up the oxygen,
there's another.
They might sink back down.
Right.
So it's when they're sinking back down, when they're becoming more dense, that's an indirect measurement of cellular respiration. So photosynthesis and cellular respiration are kind of opposite.
Very cool.
And super important chemical reactions on Earth.
Yeah, it's what keeps us going.
For sure.
Right.
So maybe while we're waiting for those, I did put into the slideshow some photos.
Get out of the way.
So a couple weeks ago, or maybe actually 2 months ago, we made COVID models here on Homework Hotline, and we didn't get a chance to decorate them. But if you're local and you want to go check some of them out, the completed projects, they're at Morris Graves Museum right now in a youth art show. So you could go to the Morris Graves Museum, and they're hanging up on the 2nd level.
Oh, that's great. Very cool.
And they're quite beautiful and amazing, well done to 7th grade McKinleyville Middle School students.
Yeah. Such a wonderful venue, too. Oh, those are beautiful.
Yes.
Good. I'm glad you got to share them with people.
We got a lot of variants.
Yeah.
In one classroom.
A lot of variants.
A lot of variants, for sure. So if you have a chance, go check them out. They're very nice. Then there's other youth art up on the walls right now.
Very cool. So.
Very nice.
That's great.
Okay, so back to our leaf discs.
So we have 3 at the top here.
Of the passion flower.
Of the passion flower, which we started first. So those are flat on the surface right now. And it looks like on the ivy, they're still flat.
So one thing to consider is, can you tell if those are the tops of the ivy leaves or the bottom?
Right, yeah, that would make
So if they went bottom up
right
in there, they might take a little bit longer.
Because the stomatas are at the bottom, and that's where that little openings, that's where the air comes out, the oxygen comes out, and the respiration. Very cool. And they're building up sugars inside, right?
Right.
So, which helps power the metabolism that you talked about, the respiration. So that's really a cool experiment. That's a wonderful demonstration.
It's a super fun one, even though it's kind of slow going and it's not quite dramatic. It is pretty exciting once they start to go.
Yeah.
And it's fun for the kids to watch photosynthesis in action, because even things like putting aquatic plants in test tubes and measuring the accumulation of the oxygen at the top of the test tube, that's subjected to a lot of student error too. Yeah. And it's hard to count the bubbles, and so this is kind of a easy one, a fun one to do at school.
Very cool.
And hopefully in the next couple of minutes our ivy will come up.
Yeah. So that's great.
So that we can check them out.
Very neat. Yeah, so like you said, it would be this would be one that would be fun to do at home. It's materials that you have at home, just baking soda and dishwashing soap.
Right.
And leaves, you just need a hole puncher, and you could even cut them out with the scissors.
Oh, yeah.
Just the nice uniformity of those.
Well, and the uniformity of the discs is kind of important,
right.
Because if there goes one of the ivy leaves.
Nice.
But if you don't have a hole punch at home, which I think these are kind of, I don't know, it seems like all paper technology is kind of going the way of the dinosaur, but the other thing you could use is a straw.
Oh, nice.
So you could use a straw as your cutting tool to punch your perfect little discs.
Yeah.
And then the more uniform your discs are, especially if you're trying to sort of measure a rate, the better your science will be.
Or you could dig an eraser. If you have a worn out pencil, just dig the eraser out, and it's got that nice metal ferrule on there. That would probably make a nice cutting tool.
And that's what we want students to do, like kind of invent things, think of solutions if you don't have exactly what you need. There's lots of ways to do that. So now we have, in the ivy, we have 2 floating.
Right, and so we're at 15 minutes since we started, so those were probably 2 minutes later. So
at least,
so a little bit slower. So that's a great demonstration. And probably one of the most important chemical reactions on Earth, as far as producing oxygen or releasing oxygen in plants. That's why we're here.
That's why all animals are here.
Yeah.
Thank you to the plants of the world.
Right.
So you can, on the camera now, you can see one of them kind of suspended.
Oh, nice. Great shot.
That is a great shot. So there's not quite, and it looks like it's moving up as we speak.
Oh, that's neat.
So that is literally measuring the rate of photosynthesis in that little mini leaf that we cut to fit in there. So pretty cool. But I'm also a nerd, so.
No, but it's cool even if you're not a nerd. So it's pretty neat.
That's debatable, I think. So this is a fun one to do at home.
Yeah, definitely so.
Again, like we live in a plant-rich environment, so you can always find some plants at home.
Right.
Probably don't punch the house plants.
Yeah, talk to your parents before you get their prized azalea, something like that,
or their orchid.
Yeah, so don't forget, coming up April 2nd is the Humboldt Math Festival at the Adorni Center, and check out the wonderful art at the Morris Graves. I'll go there soon. And thank you for being here, and Jody will be back on Thursday. So be safe, enjoy that oxygen out there.